Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and in continuation to our discussion on sea level changes and the changes with respect to relative sea level, today we will discuss about another interesting topic which is associated with this relative sea level change. So, the name of the topic is shoreline trajectory. So, in this particular class we will try to understand that how, due to relative sea level change, the shoreline moves its position and what are the effects on sedimentary successions just because of that movement. So, the interplay between relative sea level and the nature of sedimentation, these two actually controls the resultant condition. So, that resultant condition will be reflected in terms of the shift of the shoreline, and such shift of the shoreline is commonly demarcated by using two distinct terms which are very popular terms. One is called as transgression, second one regression. So, transgression and regression, these are the terms that commonly represent, signify the shift of the shoreline. So, the different relationships between relative sea level rise or fall and the sediment supply that determines the position of or nature of shift of the shoreline. So, that kind of shift because of the sediment supply and relative sea level change is called as shoreline trajectory. If there is a relative rise in the sea level, relative sea level, then the shoreline is expected to move landward. It is not always required. Because of the rise of the sea level, it will move towards the land. But when there is a rise in the relative sea level, we can expect that the shoreline will move towards the land. And if that movement is occurring, if the shoreline is shifting towards the land, that event is called as a transgression. On the other hand, if the shoreline is moving towards the sea, is moving away from the land, we call it as a regression. That regression can occur because of two reasons. One, the relative sea level is remaining constant, it is not changing, or maybe it is rising even, but the system, the depositional area, the shoreline is getting lot of sediment supply and those sediments are accumulating. Because of that accumulation, the shoreline is getting pushed away and the shoreline is showing a regression. So, when a shoreline shows that kind of regression because of sediment accumulation, we call it as a normal regression. Again, we can get a regression because of fall in the relative sea level. So, that regression which is produced by fall in the relative sea level is called as a forced regression. So, we are dealing with three different terms: transgression, when sea level is rising and because of that rise the shoreline is moving towards the land, it is called transgression. Remember, rising of sea level or relative sea level is not transgression. Transgression is the shift of the shoreline towards the land, which is caused by rise in the relative sea level. Similarly, regression is not necessarily a fall in the relative sea level. If it is by fall in the relative sea level, it is a forced regression. But a regression, shift of the shoreline towards the sea, can also occur, can also happen because of extra sediment accumulation into the system, and in that case the regression is called as a normal regression. So, let us take some examples and try to understand. So, in one area, for example, this is one area where this is the relative sea level. So, in this area maybe we can think of one reference point, something like this, maybe a tree is there. For making our understanding bit simpler, we are assuming that tectonically the basin is stable, it is not disturbed, and the sediment supply is going on at the same rate, it is not changing. I call this one as level 1 for this relative sea level. If I think of a next phase where again for the same kind of scenario, this is our reference point, the sea level was here. So, with respect to that the sea level has gone up, this is level 2. So, the earlier level was this one. So, from there the sea level has risen. So, because of that rise of the sea level, definitely the relative sea level, so the shoreline which was here is now moving towards the land. So, the new shoreline is somewhere here. So, this is one example of simple transgression. Just the reverse of this, if for the same kind of scenario, this is the basin and the first initial condition water level was this level 1, where we have this is the reference point. Now with respect to this, considering the sediment supply remaining same, tectonically the basin is stable, the sea level is falling down, it is coming down to this is level 2 now. So definitely the earlier shoreline was here, and from there the shoreline is moving over here. So laterally it is moving in this direction towards the sea. So this is an example of regression, and since this regression is happening because of the fall in the sea level, so this is an example of forced regression. We can take another example over here. This was the basin floor, this is stage 1. So with respect to this, now we can think of another scenario where the sea level is remaining constant, relative sea level is not changing, but the basin floor is going down, it is sagging, it is facing some sort of subsidence. So the earlier level, which was somewhere here, this is our reference point. Since the basin floor is now going down, relative sea level remaining as it is, so relatively the water level will come up over here because of this sagging. Relative sea level is not changing, but the basin floor is coming down. So with respect to this reference point or with respect to this shoreline position, we can expect a rise in the relative sea level, and because of that rise, again the shoreline is moving towards the land, again a case of transgression. Exactly the reverse of this will happen if there is an exhumation, if there is an uplift of the basin floor, and due to that what we expect, exactly a scenario like this where we will get a forced regression in that case also. So these are some examples, very simple examples where we can understand how transgression and regression may occur. We can think of another scenario with respect to this initial position. So if this is the basinal condition and this is the relative sea level, level 1, this is our reference point. Now in this example, we are considering that tectonically the basin is stable, as well as we can consider that the relative sea level is not changing as well, it is not rising, it is not falling as well, it is constant. So what is now going on is the sediment supply from this area. So sediments are coming in and they are getting accumulated over here gradually. So now the new shoreline is here, the earlier shoreline was here, so the shoreline is shifting in this direction just because of this accumulation of sediments. So this is one example of a normal regression. Here also the regression is occurring, shoreline is moving towards the sea. It is not because of any change in the relative sea level. It is just because of additional amount of accumulation of sediments which is pushing the shoreline towards the sea. So this is example of normal regression. So we can get any of this scenario in natural systems. So what actually happens during a transgression or a normal regression or a forced regression? So let's take examples and we try to understand what happens during a transgression and what we get in terms of the stratal stacking pattern. So this is a new term, stratal stacking pattern. What is stratal stacking pattern? How the individual strata are getting stacked during a transgression or during a regression. So during a transgression we get a particular pattern of the stratal stacking. Similarly during regression we get another pattern of stratal stacking. So that is what we are going to discuss now. So let us take example of a shore environment. In our class on facies model, I have given you the example of shore environment where we know that there will be a foreshore environment followed by a shore face environment followed by offshore transition and then offshore. So this is offshore, this is offshore transition, this is shore face and this is foreshore. These are the different sub environments that we commonly get within a shore environment. Now if I think of this is the water level, relative sea level at time t1. So relative sea level, level 1. So from this point onward, if the relative sea level starts rising, so this is the shoreline at this point at RSL 1. Now the relative sea level is rising up to this. So this is RSL 2. So what is happening now? As we have earlier discussed about the distribution of different facies types in terms of the processes, energy condition, we know that foreshore will have the coarsest sediments. In the shore face, we get further finer sediments. In the offshore transition, further finer, dominantly mud, and offshore is entirely mud depositing condition. So when the water level is rising up, so definitely the shoreline will try to move in this direction, and as the depth of water is changing and also the energy condition is changing, what we can expect, the foreshore will come over here, or maybe even less than this, foreshore will be over here. The shore face area will be somewhere here. I am just using this shade to distinguish this one. Then we can have the offshore transition, which will be like this, and finally the offshore area. If the relative sea level further changes, it goes further up, maybe at RSL 3. So, we get the sea level somewhere here. So, definitely for this rise, the shoreline is further moving towards the landward side. So, definitely the foreshore will be somewhere here, followed by the shore face, followed by the offshore transition, followed by the offshore. So, this is the offshore, this is the offshore transition, and as long as this relative sea level rise will go on, considering the sedimentation is going on at the same pace, it is not changing, tectonically the basin is stable, this pattern of shifting of the depositional environments will go on. Shoreline will move towards the land, and along with that shift in the shoreline, all the depositional environments will also shift towards the land gradually. So, that kind of shifting of the environments towards the land, we commonly use a particular term called as backstepping. So, backstepping of the individual environments is a characteristic phenomena that we observe during transgression. So, if I try to make a log somewhere here, if we try to make a log somewhere here, what we are expecting in this part? So, for this one, at the bottom part we have foreshore, over that we have shore face, maybe foreshore is continuing for some time, then we are getting shore face, and as it continues, then on this shore face we will get the offshore transition sediments. If I make a log somewhere here, what kind of succession I am expecting? At the bottom part it is shore face, followed by that we are getting offshore transition, and finally on that we are getting offshore sediments. We all know that foreshore is a very coarse sand. If I make a log here, there is the coarse sand, then the shore face is relatively finer with alternate mud units. Offshore transition is dominantly mud. If I look at over here, shore face again sand dominated with little bit of mud, offshore transition dominantly mud with some sand, and offshore is entirely mud. So, anywhere in this kind of scenario, if we try to make a log, or if we try to understand how the strata, individual facies types, they are accumulating, we get a pattern like this in terms of grain size distribution. That is, the coarser sediments are at the bottom part, finer sediments at the top part. Here also coarser sediments at the bottom part, finer sediments at the top part. So, we can call it as a fining upward succession, fining upward in terms of distribution of the grain size. Similarly, what we are getting here, the deeper facies or the distal facies, these are gradually coming over the shallower facies or the proximal facies. So, basically what we are getting, as we are moving up the succession, we are getting more deeper facies. So, deepening upward succession, and this pattern of stratal stacking where we are getting a fining upward succession, distal facies are coming over the proximal facies, that particular type of stratal stacking pattern is called as retrogradational stacking pattern. Retrogradational stratal stacking pattern. So, for transgression, ideally in ideal conditions, in ideal marginal marine environments, we can expect this kind of stratal stacking pattern, we can expect this kind of phenomena, this kind of events to occur. So, now on the reverse side, if in any rock record, if I am getting a fining upward succession, if I am getting a retrogradational pattern, if from the correlation I am getting a backstepping pattern, I can interpret that definitely there is a transgression. Definitely that transgression should be established through interpretation of the depositional environments. When I am talking about backstepping, when I am talking about the retrogradational pattern, definitely it is supported by the interpretation of the depositional environment. So, there comes the role of facies models, there comes the role of facies associations. Let us talk about a regression. So, again we take the same example, say the same shore environment where we are getting initially the foreshore. So, this is the relative sea level 1, then we get the shore face, then we get the offshore transition, and then the offshore. We are taking the same example here again to understand what is happening. So, in this case, tectonically the basin is stable, and also we are considering that this relative sea level is not changing. So, what will happen now? Continuously sediments are being supplied by the river system and they are getting distributed by rip currents and longshore currents. So, this foreshore, shore phase, offshore transition and offshore, they will get continuous supply of sediments. And where that sediment will accumulate? Definitely in front of this. This is the space available for accumulation of the sediments. So, we will get the foreshore deposited over here, the shore phase deposited over here, offshore transition here, and finally the offshore area. If the condition continues, then we will get the foreshore deposits formed over here, the shore phase over here, the offshore transition over here, and offshore over here, and again like this. So, this is the foreshore, this is the shore phase, this is the offshore transition, and this is the offshore. So, in this case, what we are getting? The shoreline was here, it is shifting to this position gradually. So, definitely this is a regression. By definition, this is a regression, and this regression is happening because of accumulation of sediments, not because of fall in the sea level, because the relative sea level is constant here. So, definitely this is an example of normal regression. Now, in this case, if we make a log somewhere here, say for example, we are making a log somewhere here, we are making a log somewhere here, or maybe somewhere here in this part. So, 1, 2, 3 different logs. So, what we will get in one? We will get shore phase deposits at the bottom, again a shore phase deposit at the bottom over that. Then we are getting a foreshore, again a foreshore at log 1. In log 2, what we are getting? At the bottom part, it is the offshore transition. On that offshore transition, we are getting shore phase. On that, again we are getting shore phase, but this shore phase is more proximal with respect to this one, and then we are getting foreshore. And if we make a log at 3, what will be the pattern? We are getting offshore transition at the bottom, followed by again offshore transition, but more proximal part of the offshore transition, followed by a shore phase, which is a distal part of the shore phase, followed by again a shore phase, which is the proximal part of the shore phase. Or if I compare that with respect to our example on phases model, so this is the lower shore phase and upper shore phase. So, in this case, what we are getting, if I take this example 2, so offshore transition is the most finest one, then we are getting the shore phase, which is the distal shore phase, so little bit coarser, then we are getting proximal shore phase or upper shore phase, further coarser, and then we have the foreshore like this. So, overall the grain size is getting coarser as the succession is developing. Similar pattern we can observe over here, offshore transition finer, offshore transition proximal little bit more sand dominated, followed by shore phase distal further sand dominated, followed by shore phase proximal further sand dominated. So, overall a coarsening upward pattern. So, this kind of succession, this kind of pattern is called as coarsening upward pattern, a coarsening up pattern. So, this is just the opposite of fining up that we get in case of a transgression. So, a coarsening upward succession, or we are getting more proximal faces coming over the distal faces. So, it is a shallowing upward succession, and whenever we get this kind of shift of the shallower or proximal faces over the distal or deeper faces, we call that pattern as progradation or progradational stratal stacking pattern, progradational succession. So, in case of normal regression, characteristically, ideally, in any marginal marine environment, we expect this kind of progradational stratal stacking pattern, we expect this kind of coarsening upward succession. So, what is progradation? Progradation is the diagnostic depositional trend for regressions, and it is commonly defined as the building forward or outward towards the sea of a shoreline, which may be due to several reasons depending on the conditions prevailing in that particular coastal area, in that particular marginal marine area. But basically the succession will gradually develop or move towards the outward side from the basin. Now, coming to the next example, which is forced regression. So, again we take the same example, same case where we are looking at the shore environment. This is the relative sea level RSL1 at time t1, and for that particular RSL1 we are getting, this is the foreshore, this is the shore face, this is the offshore transition, and finally this is the offshore. Tectonically the basin is stable, sediment supply is going on at same rate, it is not changing, it is not fluctuating. Now the relative sea level is falling. So the new relative sea level is here due to this fall. So definitely as the sea level is falling down, the amount of space available over here in this portion is changing, and as the depth is changing, the energy condition is changing. So definitely there will be a shift in these environments. So we can expect the new foreshore to develop over here, the shore face to develop over here, offshore transition and followed by offshore. So this is offshore transition, this is offshore, this is shore face and this is foreshore. If the relative sea level falls further, this becomes the relative sea level now. So RSL 3 now. So again we will get the foreshore formed over here, followed by the shore face, followed by the offshore transition and then the offshore, and it will go on like this. And along with this, as the sea level is falling, say for example, initially the shoreline was here, the next shoreline is here and the third shoreline has come down to this. So basically the shoreline is shifting towards the sea. So definitely this is a regression, and this is occurring because of fall in the relative sea level. So this is example of forced regression. When this first level of fall is occurring, say for example RSL 1 to RSL 2, then this part is subject to erosion by river systems, because river system they have to adjust their water level, and for that they have to come down to this level, and for that erosion will occur. So we get erosions over here in this part. Similarly, when the water level will come down to this, we will get erosion over here. So at any point, say for example over here, if I make a log, somewhere here, if I make a log somewhere here, what will happen? In location 1, what I am getting is a shore face deposit at the bottom, followed by a foreshore deposit which was supposed to be continuous, but that has been eroded. So we are getting an erosional surface at the top. Similarly, if this RSL fall goes on, continues, maybe after some time it will come down to over here, maybe at some level like this. So at location 2, what we can expect is maybe offshore transition at the bottom, followed by shore face overlying that, and then a foreshore, and that foreshore is truncated or eroded because of this fall. So in location 2, what we are getting is finer sediments at the bottom, followed by relatively coarser sediments on top of that, then further coarser sediments on top of that, and that part is truncated by erosions. So again in this case, for forced regression in this kind of condition, what we get, similar kind of coarsening upward succession, similar kind of progradational pattern, similar kind of shallowing upward pattern, but commonly these are truncated by a prominent erosional surface which is very commonly identified as an unconformity. If it is sustainable enough, if we can mark it or trace it along major part of the basin. So under forced regression, we expect formation of such regionally extensive erosional surfaces truncating the coarsening upward stratal stacking pattern or this kind of progradational stratal stacking pattern. And the presence of that erosion, presence of that unconformity actually points to this is a forced regression. If that unconformity is absent, it will be very difficult for us to distinguish between normal regression and forced regression, which may happen somewhere here, say for example over here in this part. So if this is log 4, so in this case what is happening, even during the fall in this offshore part, it is still underwater, and so here we are getting a continuous sedimentation. So maybe here offshore is overlain by offshore transition, overlain by shore face, overlain by foreshore. There is no erosion, because even after the fall this area is under continuous water level, and so continuous sedimentation is going on. So there is a conformable succession throughout, and we will get a coarsening upward succession over here just like a normal regression. So it will be very difficult to distinguish between whether this has formed under a forced regressive condition or a normal regressive condition. However, when it is a normal regression, the amount of accommodation, the space available for accumulation of sediments are little bit more with respect to the condition under a forced regressive condition. So in this case, what we get, the units become much thinner, very quick fluctuation in the phases associations, which we do not get in case of a normal regression. So, in case of forced regression, we get this kind of coarsening upward or progradtional pattern, which will be truncated by an unconformity at the top, particularly when we look at the marginal part of the basin. When we go into the deeper part of the basin, that unconformity may be missing. Coming to the last example, where we can take another scenario where the shoreline is constant. How it is possible? Again, we are taking the same example, marginal marine environment, where this is the relative sea level 1. And for that relative sea level, we have the foreshore, followed by the shore face, followed by the offshore transition, and finally the offshore. Tectonically, the basin is stable. Relative sea level is rising. So, we are getting RSL 2, which is actually causing like this. But by the time it is rising up, some extra amount of sediment is coming in over here, and that is accumulating in the same way. So, there is a complete balance is maintained. The amount of rise is compensated by extra amount of sediment supplied into the system. So, in this case, we are considering two variables. Rate of supply of sediment is changing, as well as the relative sea level, its position is changing. So, in this case, if it continues, say for example, it goes to RSL 3, further it is rising. So, if the same balance is maintained, what will get? Foreshore over here, followed by shore face, followed by offshore transition, and followed by offshore. So, in this case, if I make a log anywhere, say for example, over here or maybe here. So, in case of 1, what we are getting? Foreshore overladen by foreshore, overladen by foreshore. In log 2, what we are getting? Shore face overladen by shore face, overladen by shore face again. In case of log 3, it is offshore transition, overladen by offshore transition, overladen by offshore transition. So, basically there is no shift in the shoreline, because throughout this example, as you can see over here, the shoreline earlier it was here, second one was here, third one is here. So, it is not shifting in any direction. So, the shoreline is constant, and in this kind of constant condition, when we have this balance, the equilibrium in terms of relative sea level rise and sediment supply, we can get this kind of standstill condition. And when there is a standstill condition, we get deposition of same type of facies continuing for long time. So, what will be the facies pattern? It will be same kind of facies continuing in the vertical succession. So, we will get very thick accumulation of same kind of facies associations. When you are getting offshore transition, throughout for thick succession we are getting offshore transition. We are getting foreshore continuously for very thick succession, all amalgamated together. So, this kind of pattern, it is neither coarsening up nor fining up. So, this kind of pattern, when the sediments are accumulating continuously in a monotonous way, in the same way, under this kind of standstill or shoreline constant condition, the stratal stacking pattern is called as aggradational stratal stacking pattern. So, this can happen also during relative sea level rise. So, as I started at the very beginning of this class, that the definition of transgression, it is associated with rise in sea level, but at that time I pointed out to you that it is not required that every time due to rise there will be a transgression. This is one example here. Relative sea level is rising, but even after that it is not a transgression, because shoreline is not shifting. It is a standstill condition, it is a shoreline constant condition. For transgression, you require a relative sea level rise. But if there is a relative sea level rise, it is not required that there will be transgression. There can be other scenario as well that we will discuss later on with further detailing. So, to summarize now, in today's class we have discussed about the concept of shoreline trajectory in terms of transgression and regression, and within regression we have discussed about normal regression and forced regression, and we have tried to understand what are the stratal stacking pattern that will form under these transgression and regression conditions. So, there can be 4 different scenario: transgression, where we will get retrogradational stratal stacking pattern, finding upward stratal stacking pattern. In case of normal regression, we will get a coarsening upward progradational pattern. In case of a forced regression, again we will get a coarsening upward or progradational pattern, but that will be commonly associated with a truncation surface and unconformity at the top, particularly when we look at the marginal part of the basin. And the fourth one is a standstill condition, when the shoreline is not moving in either direction. then we can get a standstill condition, a shoreline constant condition where the stratal stacking pattern will be aggradational. So, these are some of the references that you can follow for further detailed study. So, thank you everybody.